Hey guys, this is take two of the fourth video, this one on scale drawings. Okay, so I didn't like the other one, and I believe I made a couple of errors, so I've wanted to perfect it a bit. I've made this one a little different. So first of all, obviously those learning intentions. So it's to understand that scale drawings can be used to depict large or small objects. So basically meaning you can use a scale drawing either to draw something that's very small, increasing the scale, okay, or drawing something that's very big, decreasing that scale so that you can fit it on one page and understand what it's showing. You're going to understand how to be able to convert from distance on a map or a diagram into actual real life. And you're going to learn to be able to convert from actual distance in real life back to a diagram or a map. So you can draw a scale diagram yourself, or you could potentially build from a scale diagram an object. So to understand the two different ways of interpreting that, and to be able to determine the scale factor given a distance on a diagram. So looking at scale factors. Okay, so once you've got the ratio, what do you multiply a distance either in real life or on a diagram by to get the actual real size, or vice versa? Okay, so scale drawings. Sorry, this just made me laugh. Obviously, they are not to scale. Okay, this video clip I would have shown you in class, but it's just the idea of showing, I'm not going to show it all now, but showing from very large objects down to very small. So at the start of the video, we saw some really, really, really minute, tiny, tiny, tiny particles and objects. Okay, then increasing to slightly bigger, so like our hydrogen atoms, so those atoms and things you would have started hearing about. Okay, there goes our virus, all right, our red blood cell. Now these kind of drawings, hang on, just let me go down here. These kind of drawings you would have to scale up to draw them, okay, because they're so small you can't see them. So you would have to increase the scale for those. We've gone past our human now. Now we're getting on to bigger items that you'd need to scale down if you drew them. As I say, we've seen this in class, or we will see this in class, and it's just giving you that perspective of different sizes. Sorry. Okay, so in terms of the questions from the diagnostic pre-test based around scale, I think they were about 13, 14, 15, 16, potentially 17, can't quite remember. So when we're doing scale drawings, it's a special application of our use of ratio. So we've learned about ratio, and this is where, or one way that ratios are quite often used, okay? The purpose of the scale drawing is to provide accurate information about an object which has dimensions that are too large or too small to fit on the page, okay? So if you're an architect, those architectural drawings that you look on need to be accurate. Okay, someone needs to be able to look at that and build the object that you've drawn. So everything on there needs to be to scale to ensure that when it's built, it looks right and operates right as well. If a scale drawing has a ratio of 1 to 1, then the drawing is exactly the same size as it would be in real life. Okay, now here's a little link. This is a blog about a girl that was looking at skate parks, and her drawings she hasn't included a scale on this. We don't actually know whether they are to scale. These ones I would say sorry, we don't actually know the scale that she's used. These I'd say are scaled down, but the actual scale ratio I'm not sure about. Obviously she'd have them drawn on there somewhere and written on there, but it's just the diagrams have been taken, the photos have been taken without them. So if you are making a portfolio in a subject area that requires design like this, you would need a scale ratio on it. And I'm not sure yet whether you've done that kind of work in tech, so or in art, but yes, scales are quite useful in all those areas. Okay, so key idea number 1. A scale drawing has exactly the same shape as the original object, but it's a different size. All scale drawings should indicate the ratio. Okay, so in this skate park here, that's the kind of 3D model. And here we can see the scale is there, and I think that says 1 to 300. So 1 unit on the map is the equivalent to 3 units in real life. Okay, we then see somewhere on there what scale what unit the measurement is in. So if it's centimeters, 1 centimeter on the map is 300 centimeters in real life. Okay, it could be millimeters. 1 millimeter on the map is 300 millimeters in real life. I would say on this it's going to be centimeters. All right, on our maps, okay, we've got a 1 to 400,000 ratio there. We've got a 1 to 40,000 ratio there. And we've got a 1 to 20,000 ratio there. Okay, so that being our biggest number means it's our biggest map. Okay, so every 1 unit on the map is the same as 40,000 in real life. So every 1 centimeter on the map would be 40,000 in real life. Okay, here every 1 centimeter on the map would be equivalent to 40,000. Sorry, that one was 400,000. This one's 40,000 in real life, and every 1 centimeter on the map there is the equivalent to 20,000 in real life. All right, key idea number 2. The scale on a drawing is written as a scale ratio, so we call it a scale ratio, and that first figure is the drawing length, and the second is the actual length. So the drawing length represents the length on the diagram, map or model, and then the actual length is in real life. Okay, so my tank drawing, hang on, I need to bring this down for a minute. Here I've got a drawing of a tank, and down the bottom here we can see its scale, okay, 1 to 76. So 1 unit on the map is the equivalent to 76 in real life. So 1 centimeter on our plan is the equivalent to 76 centimeters in real life. And here we've got a model of a A380. Okay, so 1 to 144. So 1 centimeter on the map is the equivalent to 144 centimeters in real life. Sorry, on our model, not map. Alrighty, key idea number 3. A scale ratio of 1 to 100 means the actual or real lengths are 100 times greater than the lengths on the diagram. Conversely, so the opposite, a scale of 20 to 1 means the scaled lengths on the model or on the diagram are 20 times greater than in real life. So the top example, the drawing is smaller than in real life, but on the second example, the drawing would be bigger than in real life. Okay, so here we would scale up to get the real life object, but here we would scale down to get to the real life object. Okay, so here, thinking about scale. Imagine my squares I've drawn, and no measuring because, you know, I've drawn them, are 1 centimeter by 1 centimeter. So that is our 1 to 1. Okay, now if we increase this, we've doubled it there, pretend. So that would go 1 to 2. But here we've decreased it. Okay, so our diagram is twice as big as there. Okay, and no measuring because they're probably not right. Alrighty, so let's have a think for this. A map has a scale of 1 to 50,000. How many centimetres in real life does 1 centimetre on the map equal? So 1 centimetre is equivalent to 50,000. So 50,000 centimetres. We need to include those units then because it's asked us about units. Alrighty, a map has a scale of 1 to 100. How many meters on the map does 300 meters in real life equal? So we go 300 divided by 100 equals 3. Okay, so how many meters? 3 meters. All right, because here we're looking at 1 meter. If we're talking in meters, 1 meter to 100 meters. So if we multiplied the 100 by 3, we'd have to multiply the 1 by 3. It is helpful if scales begin with 1. So if our ratios begin with a 1, then the second number in the ratio can be referred to as our scale factor. Okay, scale ratios that do not start with a 1 can be converted using equivalent ratios. So to convert a scale distance to an actual distance, you multiply the scale factor, you multiply by the scale factor, and to convert an actual distance to a scale distance, you divide by the scale factor. So I've got that drawn here. Okay, so if you've got an actual distance and you need to get to the scale distance, you divide by the scale factor. If you've got a scale distance but you want to get to an actual distance, you would multiply by that scale factor. So a map has a scale of 1 to 20,000. Find the actual distance for these. So we are going to multiply our 2 by 20. By the, sorry, 20,000, what am I on about? Okay, so that becomes 40,000 centimetres. Yes, because we're talking in centimetres. Here we've got 5 times 20,000. Okay, just remembering to keep the unit the same because the scale factor, the scale ratio up there, it's not got units. We've added the units here. And that's just done that to be awkward and confuse me. 286,000 centimetres. Excellent. All right, a model boat has a scale of 1 to 500. Find the scale distance for these actual distances. So we're going to go 50. Oops, daisy. Everything's going crazy. So we're going now 50 divided by 500. It's going to give us 0.1 meters. And this one, we're going to go, each of them we're dividing by our scale factor. Bear with me. So we've got 0.15 centimeters. It's really important that you keep your units, okay, because if you don't have your units there, all of this actually becomes completely irrelevant and meaningless. Okay, so that's dividing by the scale factor. All right, state the scale factor in the following situations. A length of 4 millimeters on a scale diagram is 50 centimeters in real life. Okay, so we've got 4 millimeters. So we've got to change them to the same units first of all. So we could go 0.4 centimeters is 50, but we like to keep whole numbers. Okay, so we're going to say 4 millimeters is 500 millimeters because 50 centimeters is 500 millimeters. All right, so we've got 4 to 500. Can we divide 500 by 4? No. We get an odd number. Okay, so can we divide it by 2? Yep, so we'd get 2 to 250. We can divide it by 4. What am I on about? So we get 1 to 125. So our scale factor is 125. My maths was just having an issue there. All right, we've got an actual length of 0.1 millimeters to 3 centimeters. Okay, we can't have the 0.1 millimeters. Yes, we can for a minute. Let's go 0.1 to 300. We're in the same units now. However, we need to make this 1 millimeter. So we've got to multiply that by 10 to get 1 millimeter, which means we multiply this by 10 to get 3,000. Okay, so they've got to be in the same units, and you want to try and get your first value, your drawing value, to the 1. Okay, so key idea number 5, conversion of units. It's important to remember how to correctly convert measurements of length when dealing with scales. So to remember that 1 kilometre is 1,000 metres, 1 metre is 100 centimetres, and a centimetre is 10 millimetres. We needed that on that last one. Okay, so this is a good diagram just to remember with your conversions. So if you've got millimetres and you want to get to centimetres, you're dividing by 1,000. Centimetres to metres, dividing by 1,000. And kilometres to metres to kilometres, divide by 1,000. Now, if you want to get from centimetres to kilometres, okay, you can either go one step and one step, or you divide by 100,000. Okay, so it's just figuring out. Most people can be comfortable just going one step at a time. You might be more comfortable going 2 steps at a time. The same this way, if you wanted to get from meters to millimeters, you could times by 100 to get your centimeters and times by 10 to get to your millimeters, or you can just multiply by 1,000. Okay, so convert 10,000 centimeters to millimeters. Okay, so we're going centimeters to millimeters, which means we are multiplying by 10. Okay, just go back to your diagram there so that you can see that. All right, we're going centimeters to millimeters, so we're multiplying by 10. So we get 100,000. All right, we've got 10,000 centimeters, and we're going to meters, so we're dividing by 100. Okay, so that's going to give us 100 meters. Okay, so that's millimeters. And then, well, we've got our, we know it's 100 meters, and we're then going to get to kilometers. So we just divide that by the 1,000. So we've gone 1, 2, 3. So we've got 0.1 kilometers. Okay, so we've got 560 meters. We want that in kilometers. So 1, 2, 3 gives us 0.56 kilometers. If we want it in centimeters, we've got to multiply by the 100. So we've got 60 centimeters, and then millimeters. Got to multiply again. So we've got 560. Oops. Oops. There we go. And that is the end of scale drawing.